Hey guys, today's video is on linear relations part 1. So like I said before in another video, relations are basically equations, graphs, mappings, or tables. We're going to talk about equations today in particular. The first type of equation you can put a relation or function in is called standard form. You remember this from Algebra 1. This says that ax plus by equals c, where a, b, and c are all integers. That means a, b, and c are not fractions. A is positive, so the leading coefficient right here cannot be negative. And again, the GCF of a, b, and c is 1, so you don't have to really worry about that, but just know that there's no fractions and the beginning can't be negative. Let's do number 1 to start off with an example. So negative 5x plus 6y equals negative 12. We want to write it in standard form. It looks good so far. There's no fractions. It's an ax plus by equals c. But again, this beginning part is negative. What we can do to make it unnegative is times this whole quantity, everything, times by a negative 1. That means negative 5x is going to be 5x. 6y is going to turn negative, and then 12 is going to turn to the positive right there, and we are good. Let's do another example. Let's scroll on down. Number 5. It looks again ax plus by equals c, so that's good, but there are fractions. I'm going to get rid of the fractions by multiplying, not by 4. Think about what number you can multiply to get rid of the 4 and the 3. I'm going to multiply by, let's try 12. I'm going to times everything by 12 over 1, and let's see what that comes out to be. So 3/4 times 12 over 1. I'm going to do some cross simplification. That makes 9 x's. And then I'm going to do 1/3 times 12 over 1. Again, cross simplification. That makes 4. And it's okay that the y term is negative. All we care about the negative is in front. Equals, and don't forget to multiply the c term by 12 to make 1 times 12 is 12. And that is all you got to know for standard form. The second type of form that we're going to talk about today is called slope-intercept form. And that is the one that I think you know most about. Y equals mx plus b, where m is the slope and b is the y-intercept. So you don't need to know. I'm just going to talk about y equals mx plus b. There is really no other form we're going to talk about. Probably remember slope. We're going to talk about 4 types of slope. One type is positive. That's when it goes up from left to right. You can have a negative slope. You can have zero slope. That's when you have a horizontal line. Or you can have an undefined or no slope. Undefined or no slope are the same thing. That's a vertical line going like that. So 4 types of slope. Little recap review of Algebra 1. What we're going to do now is take slope-intercept and just graph it. Just a recap of that as well. What you do first is you take the b term, in this case it's positive 7, and we plot 7 on the y-axis. There's 7. And then what you're going to do is take the slope and think of it as rise over run, meaning that we're rising 2 and we're running 5. That means up 2 and right 5. But if you're looking at the graph, you can't really go up 2 and then 1, 2, 3, 4, 5. It doesn't really fit on the graph. We have to get points in this second quadrant. So what we can do is go down 2, that means negative 2, and then over negative 5, which is the same thing on the line. Down 2, 1, 2, 3, 4, 5. And that gives us a nice line graphing in slope-intercept form. Let's do another one. Let's do number 10. Number 10 is a little different because we have to convert this form to slope-intercept. So solving for y, we get y equal to negative 4x plus 1, basically moving everything else over. So here is our y-intercept of 1, and our slope is -4 right here. The slope of -4 is like saying -4 over 1. So that means you're going down 4, right 1. 1, 2, 3, 4, right 1. You can also go up 4, 1, 2, 3, 4, and left 1 to continue that pattern of the line. And I'm going to keep on going that way. Don't forget arrows when drawing your lines. Sorry that it's not perfectly straight, but again, this is how you graph in slope-intercept form. Just a refresher there. What I want to show you is how to graph these on your calculator if you weren't ever shown to. I'm going to turn my calculator on, and I'm going to show you and prove that number 10, y equals -4x plus 1, actually looks like this graph here. You're going to press y equals on the top left, and then you're going to type in -4, x is over here, plus 1. Then you're going to click graph on the top right, and it will look just like your graph there. If you wanted to see specific ordered pairs or points, you would want to go to the table, which is in blue here. So you're going to click the blue button second, and then table, which is the graph. And you can go up or down to look at all your ordered pairs that are on that line. Go back to graph, and if you want to change anything, go back to y equals. Hopefully that helps a little bit. Quick talk about vertical and horizontal lines. Vertical lines are up and down like this, and you write them as x equals. So this one would be x equals 1, 2, -3. Horizontal lines are written as y equals. So this would be at y equals +1. An acronym that I've taught my Algebra 1 students is to use HOYVUX, HOYVUX. That helps you remember. H stands for horizontal, 0 slope, and then you write it as y equals. VUX is V stands for vertical, U is an undefined slope, and you write it as x equals. So those help you remember your equations for horizontal and vertical. We're going to talk next about parallel and perpendicular, a little recap. Parallel lines have the same slope, so the slopes are equal. Perpendicular lines have slopes that are what's called opposite reciprocal, meaning that you're going to flip the slope and also take the opposite sign, positive to negative, negative to positive. Let's do a couple examples. Number 13, we have to determine whether those two are parallel, perpendicular, or neither. Before you determine that, you have to convert each equation into slope-intercept form to find the slope of each line. So I'm going to solve for y. Y equals -10x, moving that over. And then dividing by 5 and simplifying, we get y equals -2x plus 1. So the slope here is -2. And then in the other equation, I'm going to solve for y. I'm going to minus this 16 over here to get 2y equals -x minus 16. Dividing everything by 2, we get y to be a -1/2 x minus 8. Now let's compare these slopes, -2 and -1/2. They're not the same, so we can cross off parallel. You might think they're perpendicular because they're flipped, but they're not perpendicular because they're not opposite signs, one positive, one negative. So these are neither. Okay, again, perpendicular will need to look like that, intersecting at a right angle. Number 16 is the next one I want to do. X equals 2 is a vertical line just like this. And then y equals 2 is a horizontal line looking like that. You don't really even need to look at the slopes or look at the graph. You can see that they are, in fact, intersecting at a right angle. They are perpendicular. This is the symbol for perpendicular, or you can write the actual word perpendicular. On a side note, the symbol for parallel looks like that. Okay, last thing we got to talk about are intercepts. The x-intercept is basically where the graph crosses the x-axis The y-intercept is where the graph crosses. The y-axis, x-intercepts are probably more important in my opinion. X-intercepts are referred to as zeros, solutions, or roots to the equation. Basically, whenever I ask zeros, solutions, or roots, you're looking at the x-intercept of the graph. We can find x-intercepts algebraically if we're not given the graph. Real easy. To find the x and y intercepts, let's do this equation right here. To find the x-intercepts, you're going to take y and put 0 in for y, because x-intercepts are when the y coordinate is 0. Solving for x, we get x to be minus the 5 divided by -2, a positive 5/2. You write your answer to an x-intercept as an ordered pair. So you'd write 5/2, 0. And then the y-intercept is when you put a 0 in for the x coordinate. Solving for y, we get y to be 5. And of course, it's the same thing as the y-intercept in the slope-intercept form. And we write our answer as an ordered pair as 0, 5. These are your two intercepts. That's how you solve x and y intercepts algebraically. If you want, you can totally just continue working on some of these problems in the next couple of pages, graphing these, putting them into slope-intercept form, and also finding x and y intercepts. Maybe try this fraction problem here in number 6. Have a great night, guys. See you guys next time.